All right, so we're just reviewing volume today, 11.4 and 11.5. So that's the volume of prisms, cylinders, pyramids, and cones. Should be pretty quick today. So your first practice problem, I have kind of two pieces or two practice problems I want us to work on today. The first thing is a do now that I often will do in class is to draw diagrams and then find the volume of each polyhedron and then list volumes from greatest to smallest. So in A, you have a square-based pyramid with base edges of 13 inches and height of 21 inches. B is a cone with a diameter of 18 inches and a height of 15 inches. And then C is a rectangular prism, which is 6 inches by 14 inches by 15 inches. So pause here, please. Take a moment and solve this problem. Figure out the volumes from greatest to smallest, and we'll go over them in just a minute. Okay, so I'm just going to go ahead and put my answers up here. The volume of the pyramid was 1,183 inches cubed. The volume of the cone was 1,271.7 inches cubed, and the volume of the prism was 1,260 inches cubed. And again, I don't have my work here, but if this was a test or quiz or an exit task or whatever if that we were doing in class, I would always ask you, right, make sure that you show your work, show your diagrams, etc. So if our goal was to list them from smallest to largest, the pyramid is obviously the smallest, and then the prism is next, and then the cone is the largest one at 1,271.7 inches cubed. Notice, by the way, that you are going to have to multiply this out by pi in order to compare it accurately with the pyramid and the prism, and that you may have a slightly different number here than I do based on the number for pi that you used, whether you use 3.14 or the calculator button has a lot more decimals in it, but it should still be a correct approximation, pretty close to 1,271. So our second problem of the day to work on, which I think this is so funny considering the circumstances, I mentioned this in our PowerPoint yesterday. I do this problem with my students every year, and this year it just seems especially relevant and timely to be talking about toilet paper in our math lessons. So this is just kind of, just kind of a silly little intro. Advertising leads us to believe that toilet paper from Charmin is the best. At this point, I would say any toilet paper is the best. But our goal is to find the volume of the toilet paper roll given the dimensions down here. And we are going to round our answers to the nearest hundred. So that means we're not going to leave it in terms of pi, right? We'll actually have to multiply it out. So the volume of the outer cylinder, I'm actually going to do here kind of the first option that I talked about yesterday, where I find the total volume of the large cylinder, the total volume of the inside cylinder here, and then subtract out that middle volume. So that's kind of different from what I was explaining yesterday, where you could, like another option is that you could find the volume of this, just kind of the outside of the toilet paper with subtracting this section in here. So take a minute, please, and pause if you like, and take a couple minutes to try this out yourself and just sort of test yourself and see how you're doing. And I'm going to go ahead and get started on finding the volume of the outer cylinder here. So my radius of my outer cylinder, the total diameter is 3.8 inches. So be careful, right? Half of that, the radius, will be 1.9 inches. That means that the area of the base, pi r squared, is going to be 3.61 pi inches squared. And then the volume will be 3.61 pi times 4 inches, which gives us a total volume of 14.44 pi inches cubed. So again, it says to round your answer to the nearest hundredth. I'm just going to leave it in terms of pi all the way until the very end, and then at the end, I'll multiply it out. So the volume of the inner cylinder, right, this is the volume of the total, like everything, including that little middle piece there. Since the diameter is 1.2 inches, half of it, the radius would be 0.6 inches for the radius. The area of the base, pi r squared, will be 0.36 pi inches squared. And then we want to multiply it by the height, which is 4 inches, and that gives me a volume of that inner kind of cylinder there, the toilet paper roll, 1.44 pi inches cubed. So the total volume, I'm going to take the outer volume, right, the toilet paper out here, and subtract that toilet paper roll space, 1.44 pi, and that gives me a total volume of 13 pi inches cubed. And it did ask us to leave it in to the nearest hundredth instead of in terms of pi. So if I multiply that out using just 3.14, not the pi button in my calculator, I get 40.82 inches cubed. And if you use the pi button in your calculator, let me see if I can find it here. The pi button in your calculator will also give you 40.8, but it'll be 40.84. So we're going to be pretty close either way. Okay, so that's all for today. Your homework tonight is to do the 11.4, 11.5 worksheet, and then we will have another exit task kind of quiz on Teams this week, which will go from Thursday at noon until Friday at noon, and I'm going to do my best this week to actually get it out to you on time. I'm not driving across the country, so it should be a little bit, I should be a little bit more accurate and responsive as far as times go. Next week is our last week of school, if you can believe it. So we are going to have a test next week. And again, remember, it's going to be pretty straightforward, and it won't negatively affect your grade at all. It's just kind of a way for you to check in. And that'll be our last test of the year, if you can believe it. So keep on working, do your exit task this week, and I'll hopefully see you guys at our meeting on Thursday.